Hello, everyone. Welcome to our first session of the year of the Signals Connect Community Series. You may have noticed that we combined the Signals Notebook and Signals Research Suite Connects into a single Connect. Would you advance the slide, Zev?
Yep.
Yeah, so we did this combination for two reasons, and I wanted to kind of show the slide here. So first of all, as you can see from the slide, we have Signals Notebook and Signals Research Suite are part of the same Signals platform, which is founded on the native integration of ChemDraw for chemical communication and Spotfire for advanced analytics and visualization. So from a technology perspective, both Signals Notebook and Signals Research Suite share technology. And because the two share in technology, this leads me to the second reason for combining the two connects. We want to make it easier for you to hear about all the latest innovations in both connects so that you didn't have to attend two different webinars. So my name is Chris Stump, and I'm the Product Marketing Manager for Signals Research Suite and Signals Synergy at Revvity Signals, and I will be your moderator for this session. And if you tuned in expecting to hear Diana Tran, she'll be back in a couple months. She's on maternity leave right now. So we have a fantastic webinar for you today. But before I introduce my co-presenter, Zev, I want to share what you're going to learn today. So would you advance the next slide, Zev?
Yep.
All right. So what you're going to learn today is we're gonna focus on three areas that we're working on with regards to uh, artificial intelligence and machine learning and the Signals Research Suite, our Signals platform. So large language models and Signals, science-specific artificial intelligence and machine learning, and then you really can't do any of this without having AI-ready data. So we're going to hit on that as well. Next slide, please. So I need to also give you just a little bit of context for kind of what our strategy is so that a lot of this will make sense. So let me see here. I just lost my place here. So first of all, what we're doing here is we're focusing on augmented intelligence, and Zev's going to explain to you, what we mean by that in a moment. But mainly what that means is that we're focusing on making your work easier and reducing the mundane task. And so, Zev, like I said, we'll hit on that in a moment. And then we're focusing on three pillars with regards to our strategy. So the first pillar is the generative AI and large language models to do things like semantic search, help you summarize your work, and in general, just kind of serve as a co-pilot for you. And then the next pillar is scientific AI and machine learning models. So we know that the AI machine learning kind of environment is evolving very quickly right now. So we want to streamline how you integrate those third-party AI machine learning tools into the platform. So if you're using ones yourself, also we will be leveraging this kind of technology as well to integrate them ourselves. And so this will allow us to implement things like chemical reaction recommendations and antibody developability dashboards, which Zev is going to show you some examples here in a moment. And then finally, as I alluded to a moment ago, you can't really do any of this AI machine learning. You go to conferences, people talk about this, that you got to have this foundation of having your data AI ready. And so we are, kind of focusing on ensuring that your data is kind of properly harmonized and contextualized. And we've been doing this for ages because of the necessity of doing that for the analytics and visualization. But there's additional requirements now required for AI, just for AI and machine learning that we are also implementing. Okay, and then next slide, please, Zev. Yep. So it gives me great pleasure to introduce my co-presenter, Zev Visotowski. Zev is the Senior Principal Marketing Manager for Biologics at Revvity Signals, and he has a PhD in neuroscience from the University of California at Riverside. Welcome, Zev.
Hey, everyone.
All right, so before I jump into the presentation, I have three reminders. So first, this webinar is being recorded, and I know a lot of people are interested in maybe sharing with their colleagues or listening again. So this is recorded, so you'll be getting a link in the next couple of days. Second, we plan to have Q&A at the end. And so during the presentation, if you have questions, you can just enter those in the Q&A box. And then third, Zev, yeah, thank you, Zev. So I just want to remind you that what we're going to show you is kind of an advanced view of our intentions with regards to AI, and some things may change. So I need to show you the safe harbor statement. Much of what we will show is under development and may change from what you see, or may not be delivered on time or at all. So I'll give you a moment just to skim over this. Okay. All right. So without further ado, Zeb, maybe advance to the next slide.
Hmm.
Okay. So I think a good place, and I alluded to this earlier, is maybe give your take on augmented intelligence, and then after that maybe jump into some of the examples of large language models that we've been working on. I'll
Yeah,
turn it over to you, Zeph.
thanks. Yeah, so Chris asked a really interesting question, or at least to clarify, some of you may already know, but for those who don't, so what is augmented intelligence, or what do we mean by that? And uh, really, the goal to answer this question directly is, augmented intelligence is focusing at the human at the center. So in this case, the scientist. And so we are not in the business of revolutionizing science. Science is being done in very similar ways as it's been done. We're just trying to make it a lot easier and to have enhance the way that reports or things are being done. And you're going to hear on the news that you know the, especially these days with DeepSeek and all these other companies coming out that people's jobs are going to be replaced and et cetera. Like that is not our goal at all. Our goal is to support scientists doing science. Really making it easier, more effective. So when they're at the bench, they can maximize their hours versus bogging down notation of that science. All right, so we're going to cover today just some of the ways that we're working to improve scientists' lives using Revvity Signals software. So we'll begin with a summary of how we are incorporating large language models and generative AI. And I think, as many of you know, this space, that in this space, in terms of software, like as I mentioned, ChatGPT, Claude, and Copilot, and others, they are truly revolutionizing the way we're interacting with information. New level on intelligence to our communications and data sets, which allow, hopefully, in a joyful, efficient experience. And our goal is really to drive that quality within our scientists' lives. And although these don't have anything to do with the specific science, like directly that's happening, they're going to have a large measurable impact with the amount of time savings within notating the science or searching or communicating within our products. And so we kicked off this project in early 2024, and this list, as you can see on the left, is continuing to grow today because, of time limitations. Though we're going to showcase today semantic search. It is a simple and powerful new way to find your relevant information. So today, most of you are familiar with Signal's search capabilities. However, for those of you who are just learning, we have a very extensive full text search within Signal's research suite for documents that are uploaded. And when you type in a piece of text, it's found within the document that's attached to the notebook entry, for example. And we've added a button that basically allows you, our goal is to allow the semantic search to go through a large language model, interpret the questions, and bring answers based on the model. And so furthermore, because these models are multilingual, it doesn't necessarily matter what language you search in. And we'll see that within the short demonstration that I have for you. Okay. So I'm going to start this off. So before I jump in though, moving into the demonstration, we're going to look at many different notebook entries here that contain content for us to search from. And each of these searches will bring back relevant notebook entries related to the query. So let's go ahead and take a look at the first one. We're going to look at, I think, like the search term solar system or solar system planets, and you can see that it showcases both the exact and relevant information. We have vaccine development, and we'll put and when we search for that, it will pull up, relevant information in terms of RNA, DNA, etc. And before I jump into the next one, we're going to look at the multilingual aspects. So in this particular example, we're going to look at something that is translated into German. So we'll take this search again, as I mentioned. Oh, it started over. Sorry. Hold on. Let me scoot that forward. Okay, give it a second. Okay, so this is the one I just showed you. Next, we're going to search for something in German. And so we're going to translate this search term into German, and we're going to search within the experimental notebook entry, and you'll find that it will pull it up. And then I have one other example when we search within Mandarin, I believe, and again, it will pull that up. Uh, so what's really exciting, as I'm going to go back to the original slide here so you can kind of see all of this, is not exactly what um, that just the semantic search will do, but what all of these can kind of do together. And because these are connected to the notebook right away. We're supporting scientists summarizing their work from publications, helping write protocols, and it's all within in the software. So what that means is, it's safe. We're not, leaking any intellectual information that doesn't meet your company's requirements. So really, being able to do all of those tasks that you want in an effective and safe for you to use.
So Zev, I guess you and I talk to a lot of people, and one of the things I think people talk about in their laboratories is a lot of the data is unconnected, in data silos and things like that. So this seems to be like going to be really powerful for people because it seems like it kind of has the ability to kind of like bring together seemingly unrelated stuff and just put it all together in the proper context. So that's really cool.
Yeah. One other example that we actually heard from a client, or at least someone who was in this space thinking about it. So, if we take a more scientific example, imagine you're outsourcing your science to a CRO. Maybe you're using Signals Research Suite with Synergy, our new outsourcing tool, and you're writing in a non-English language, or the company who's doing your outsourcing is writing in a non-English language, and you'd like to be able to search or summarize that in your own language. This could be a possible way of using it. So, really trying to bring the communication aspect and the ease of transmitting information, faster and in a more efficient way.
Yeah,
So with that, oh,
yeah,
yeah,
I entirely
no, go
agree
ahead,
with
Chris.
that, Jeff. Yeah, yeah. I think that the language aspect is going to be extremely powerful. So glad you
Yeah,
glad you kind of brought that up and shared that. So the other thing, you and I are both scientists, so I'm just kind of curious, kind of what you have to show us from the perspective of kind of like scientific examples and kind of bringing in like third party and integrating things into signals
yeah,
and platform.
that's a great question. So as Chris introduced, we're going to move on to these scientific use cases. But before I dive into each of the three, I just wanted to talk, unlike the large language learning, the models, there's really not one model that fits all of the particular needs. It's many models, it's hundreds, maybe even thousands. And we'll develop these. We have partners and internally developed models that will fit, the particular scientific artificial intelligent use case. So with that, I'll jump into these. We're going to talk about reaction planning. And instead of having an AI as a separate tool, we've integrated this right where the chemists, or need it or are already working with it, either within ChemDraw or Signals Research Suite. So let me introduce our AI reaction planning. As I mentioned, it's already here. It's going to be right where you need it. And I'm going to jump right into the demonstration and we can walk through. So let me show you this example. It's a small molecule integration with ChemDraw. And whether the scientists are using ChemDraw standalone or with Signals Research Suite, this tool enhances the workflow as they plan to draw chemical reactions. And we've integrated a deep neural network algorithm trained on small but a highly curated set. So hold on a second, it's going a little bit faster than I wanted it to. Let me start that over. So what you're seeing here is instead of drawing the reaction in front of you, which would not be a great use of your time, I have a couple of reactions here. And what you'll see is I'm able to basically put that into, excuse me, put that directly. So when I click on that, there's your reaction here. Now, what you'll see is as I pull up a reaction, the tool will automatically start to provide me some recommendations down here in the bottom left. So whether that's catalysts or solvents or other things like that. And when you select an example of that, which was going a little bit fast. So first, uh, hold on a second. I want to show you that's important. So first, I know as many chemists, on here probably know a lot about their reactions, but let's just pretend, for example, they may not. You're able to first see how the reaction is being done. So it's kind of, mapping that so you can kind of see that and support you through. Oh my, this is not clicking very nicely today. And then furthermore, when you actually, you know, select a particular uh, catalyst, you can see that there's an actual score or a ranking that we have for this. And these are and a confidence score. And what's really powerful here is scientists can add any catalyst into their drawing with a single click. The same goes with solvents. So it's, the goal is really the practical details like safety and hazard, environmental aspects, but it you know, brings these tools right within the hands of the chemists or the scientists who are at the bench doing this. And rather than replacing the chemist expertise, we're kind of guiding them through it if they need this. And I'll say we're currently evaluating its performance, so we do need feedback from synthetic chemists that really understand its accuracy and utility. And what excites us most isn't just this specific application, but how it demonstrates the potential to integrate intelligent assistance exactly where the scientists need it in their workflow. So I'll let this finish so you can kind of see that. And then this is the solvent scoring, which you already surmised. So So that's what I wanted to show from the from the chemical recommendation reaction.
So Zev, just one before we move on to the next one. So I think you showed some confidence scoring in there, and
Mhm.
I was just curious how how you see teams using that in practice.
Yeah, I think it's a really good question, and I think what's really important is we're really working to develop this alongside chemists. So the data we're using is valuable and actionable, and we are looking for others who are in interest in providing their input and how to improve this model and overall reaction recommendation capability.
Okay, cool. So so I know that you being a biologist, I know you got some examples and from biology to show us. So would you maybe show you what you got there in your grab bag of goodies here?
Right. So I'll shift to our next, yeah, I'll shift to our next example. So moving from small molecules to large molecules, in this particular, what we're showing is as antibody developability. So this tool helps scientists predict which antibodies might be most promising for their particular use case. Analyzing multiple sequence variations, and this type of analysis is traditionally requires, specialized expertise. So if you're a bench scientist, you typically need to collect the data, hand it off to a bioinformatician expert. And then, it might take them weeks or, because they're doing many different things at once, they run complex either command line or other tools calculations before getting back a report. And I think our goal is really to change that dynamic, just putting it in the hands of the bench scientists as soon as possible so that they can be as efficient as they can. And so we've created a suite of integrated tools that makes this complex machine learning calculations directly accessible, as I mentioned. And like things like antibody numbering calculations, sequence liability identifications, 3D structure predictions, using immune builder models, and surface accessibility calculations for identified liabilities. So let's go ahead and take a look at that. All right. So I'm going to show you how this works in practice. And in this video, you'll see a scientist working on a list of sequences, in this case, I think 10 different antibodies. And with a single click on the dashboard, they can input their heavy and light chain sequences and select which ones to analyze. So right now we're looking at a search and we're basically searching the whole list, all rows, all heavy and light chains. And then the system will automatically perform calculations and present results in an intuitive dashboard that includes an interactive 3D structure. So just give it a second. We're going to jump to that. Molecular level visualization and liability points. So the 3D structures on the left, top left. Molecular level visualization and liability points, comprehensive liability and annotations, and developability metrics. So on the bottom here, you can see bottom left, you can see all of these like the little dots that will talk to the various different liabilities. And all in all, as you kind of walk through this, what's truly exciting isn't just the individual calculations; it's how we've made it this powerful and analysis accessible to bench scientists, so they can now get immediate insights while staying focused on their core expertise, the science itself. So you're able to see, the various different notes here. Let me see if the video's ended. Okay. And then the one I'll leave us on is the top right, the antibody developability metrics. You could imagine that green bar maybe is sort of the uh, a good area or the place where you want to see over many different assays or many different data types. And so this is really important when you're making decisions because a lot of these typically will live in a PowerPoint somewhere in a meeting that was done. Why do we make this decision? And why did we go forward with this candidate or forward with this mechanism of action or whatnot? And so you can, really see a lot of that here and make informed choices.
So I think that's a good point about that. That green bar there. It's like having just all this data in one spot seems to be really powerful.
Yeah,
So so I know that another topic that we wanted to cover was and given kind of Revvity's expertise with cell imaging technology and some stuff that you showed me as we were preparing for this is I think people will be really interested in some of the examples we have with like cell imaging. You'd like to
absolutely.
go ahead and
Yeah,
take us there? Yep.
it's definitely one of the passions that we have as a company as a whole. So before I dive in to the imaging artificial intelligence capabilities, though, I really wanted to highlight what makes our approach unique. And I think what really does make us unique is we bring decades, multiple decades actually, of experience across the entire imaging workflow. So from creating reagents like CRISPR cell lines to manufacturing cells and uh, having imaging instruments and other instruments, and then developing the analysis software. We'll focus on this piece here. We have that end-to-end view, and that expertise really gives us a deep understanding of our customers' challenges, and we can use this complete picture from sample preparation through final analysis to allow us to develop truly, integrated solutions. So let's focus on our latest developments of imaging analysis, where we're applying artificial intelligence, or really machine learning in this case, to transform how scientists work with their imaging data. So Signals Image Artist is a very similar to the Signals Research Suite in the fact that it's a centralized place for raw imaging data. And it's not just Revvity imaging instruments, but most imaging instruments that can, push data, via API can share or can push that raw data to the Signals Image Artist. So all of the primary analysis can be performed, and again, as I mentioned, we're working with over a decades of experience in this space, building on various different imaging algorithms and capabilities. And having built these, algorithmic ways, we're now going from these traditional models of data capture to this, deep learning neural network. And it's, I don't want to say it's like flipping a switch, but we have a lot of the data that we've captured over decades. So it's, really a powerful model that we've captured lots of data to make it really useful and meaningful for our customers. Um, we are using it in bright field imaging, which I'll talk a little bit more about. But the most important thing to note is it's more biologically relevant live cells, and ultimately this data will be combined into the Signals Research Suite for a more holistic analysis of the data sets. So let's go ahead and jump in. As I mentioned, bright field imaging will allow our scientists to study more biologically relevant questions. That's the first part. And if you are still staining, okay, you can add an additional channel to measure another, so to get the most out of your data, or the most out of your cells, I should say. And we're using an upper and a lower bright field measure. And with those two parts, we're able, through deep learning, to find the cell nuclei via phenologic AI. So that's the uh, add-on that we're able to do. And furthermore, we can calculate these phase image to yield both nucleus and cytoplasm from the digital phase image. So I'll show you how this looks within the product. And now, as we have been in this space, as I mentioned, for multiple decades, we have a deep expertise, which means our training, as I just want to reiterate, our training set is vast and allows a phenologic AI to be a very strong machine learning model for bright field imaging. So let's go ahead and show this. So in this video of Signals Image Artist, you'll see both the lower and the upper bright field channels for capture. And within 2 clicks, phenologic AI can detect the nucleus within each cell. So find nucleus, and now you're left looking at a single small square. Oh yeah, sorry. So this is that's the image there. What I wanted to quickly mention is this single small orange square here is one visual, standpoint in this vast amount of data that we've captured from a primary data capture. So once you kind of let the algorithm work on this particular cell, as in the single orange cell, it will then, with one, sort of press of a button, it will then calculate all of the nucleus and all of the calculations for the entire image set. So that's important to note. And then let's move to the both. Oops, hold on, it's showing the same video. Okay, so now let's move to the finding the cell body here. So now that the nucleus are found, um, the phenologic AI can calculate the phase image and overlay both the nucleus and the cytoplasm in a single image. So this is really powerful. Again, to grab all of the data in regards to this, it's much faster than doing this in a manual way. It's much more standardized. And this is just the start of where phenologic will allow scientists to capture information. And let me go to the next. So now thinking about, more biologically relevant and, not non-fixed cells, we're able to ask questions and get to things that we wouldn't have been able to before. And so really, because these are live cells, we can start to capture their movement. We can start to get data sets around that. We can run scratch assays, which is the one on the right, to look at cell migration. And these are only two of hundreds of ways that phenologic AI with live cells can support biologically relevant science to answer questions that, again, maybe had been locked with more fixed or more time point required methods. So in this next slide, I think what's really important here is, oops, went too far, is this is great. I think it's really impactful to see the phenologic AI be able to capture all of this data, but I would be it would be limited if it kind of stays in a single silo, like even within Signals Image Artists. So what we've done, and the importance of at Revvity Signals, is we've really created this way to integrate and do the secondary data analysis and then have that more or less automated through our system. So what you're looking at here is the ability to capture primary cell data or various different measurements of your cells. You can see those on the left. And let's say this is a kind of like a principal component analysis of some sort, right? Where we're trying to understand and running this through a standardized workflow for our scientists. So it's going to be standardized whether I'm in, on the East Coast or the West Coast of a company working with the same data set. But furthermore, pushing that into the Signals Research Suite so that now we can look at this imaging data as a piece or a slice of the data in concert with the other data sets, other screenings or other binding assays, et cetera, right? So this is the point is, not only is it just here's this great, beautiful imaging data, but now how are we using it to make it really impactful and harmonized through our data sets?
So Zeb, I think this, this fact that we can hand this off from Signals Image Artist to Signals Research Suite is really cool. Being able to do principal component analysis. I think the thing that for me personally though was the thing that was the coolest part is, I'm, a lot of people are probably familiar with doing like the cell staining, and you have like the 7 or 8 different dyes, and
Mhm.
and and having to work with that, and what you showed here with this label free analysis, I think that's
Right.
really cool, and it seems to be really powerful.
Yeah. I wish we had all the time to talk about this. Chris will talk about at the end of our webinar another place for you to come if you're more interested in fleshing this out. But I know that there are some big companies that are also moving in this trend, and so we're excited to be a part of that.
And maybe another thing, Zev, is that maybe we give a plug. You're going to be doing a webinar in a few weeks, right? Kind of on this
That's
topic.
correct.
Yep.
Yep. Yeah. So if you guys are interested, we'll share those details.
Yeah.
Okay. So, oh,
Yep.
go ahead.
Yep.
Yeah.
Let
Go
me
ahead, Chris.
let's just jump into the next topic. I think that if people are interested in that in his topic, we can include that in the email. The other thing, like I alluded to at the beginning, a lot of this stuff that we're showing doesn't work unless kind of you have your data kind of ready to go and harmonized and contextualized. So Zev has some examples and kind of some of our philosophy on how we're going about this.
Yep. Yeah, so I mean, I think it's a really excellent point. Without connecting the data in a structured way for comparison or harmonization, all of kind of what we've shown is sort of, I think, a little bit pointless. It's in a silo. So let's talk about what happens when all of these results, whether they're coming from high content screening or high throughput techniques, our instruments or third-party platforms. All this data needs to be centralized or at least connected. And that's why we built sort of the what we're calling the data factory portion of Signals Research Suite. So this technology is specifically designed to index all of the knowledge, your assay data, results from every type of experiment, information about constructs, whether they're small molecules or biologics, novel therapeutic modalities. But really what makes it truly powerful is how it makes the data immediately available for the analytics. So scientists can easily query across different projects, therapeutic targets, and experiment types, bringing everything together for the visual analytics or AI and ML algorithms. And what sets the central kind of data factory portion of Signals Research Suite apart is its scientific intelligence. It's really built specifically for scientific data, both chemistry, sequencing capabilities, right there. You can perform, as I mentioned, chemistry-aware searches and blast sequence queries, enabling your bench scientists to rapidly gather data for various different analysis. And back to kind of Chris's point and what we've heard from our customers at shows and talking with them directly, what we've learned with our with implementing AI or machine learning is the data exists. These companies have run the experiments. They have a wealth and of valuable data. The challenge isn't having the data; it's accessing it, it's formatting it, it's bringing it together in a way that's useful. So this is why we've really designed it in this way from the ground up to capture and centralize this data, from the moment it's generated. And this approach really enables scientists to create sophisticated, as I mentioned, dashboards through simple queries, whether they're working in sequence data, chemical structures, or predictive models. But what's really powerful is the extensibility. We're not talking about one algorithm. Remember, we're talking about hundreds. So we built these careful extension points to our platform so we can integrate whatever algorithms are most relevant to your science. So that's how we created the antibody dashboard on the left here, or what I showed earlier. When you're using Spotfire's native capabilities for data transformation, our ChemScript extension in the center, for chemistry visualizations. And it's a combination of this intelligent data management and flexible algorithm integration that really gives the scientists, these powerful new tools to accelerate their work, or at least to have insights into their work, which hopefully will give them the time and thoughts to really improve the quality of their experiments that they do afterward. So, and while this kind of analysis is possible today, it typically requires really deep expertise, and it's an inefficient process, the data gathering and the algorithm execution. And we believe, making this AI-powered insights directly accessible to bench scientists will be game-changing, at least in the sense that, giving them time back, making it so much easier, getting them the answers they want faster. So we're excited to work with you, and we're excited to work with our current teams and partners to identify and rapidly integrate these algorithms that will have the biggest impact on your scientific workflows. And so with that, I'm going to turn it over to Chris.
Yeah, so Zeb, I just want to say thank you for, going through all that, sharing your expertise today. You covered a lot of ground. You started out with large language models and showed us some semantic search and went all the way to that the image analysis and the in our AI ready data strategy. And so what I'd like to do now is just give everybody kind of a little bit of a summary before we jump into Q&A. Um, and first of all, before I give you the summary, I just want to, that QR code that's right there in the center or at the side of the screen, that will take you to our landing page that we have for AI and machine learning. So that if you have more questions, you like to have, maybe some more documents, things like that, that would be a good source to go to. So that now, just let me summarize a few things, and then we'll go to Q&A. So first of all, Signals Notebook and Signals Research Suite help you structure data while you're adding it. And that's important because that's part of this AI ready data. So this helps ensure that you have your data in a consistent, organized format so it is ready for data reuse. And that's been important for the analytics and visualization that we've been doing with Spotfire, and it's equally important and probably more important with the AI and machine learning. Second, Signals Notebook helps the users capture that data. Signals Research Suite provides a Signals platform for data capture and analytics, as I alluded to just a moment ago. And then third, this means that if you're using Signals Notebook or Signals Research Suite, your data is accessible to AI. In other words, you're making your data AI ready. And we've had at our Nexus users meeting over the last couple of years, people already before we actually were we were talking about like a presentation like this using like Signals Notebook for just getting contextualizing all their data and then plugging it into an AI system that they were using. And then the fourth point I would make is that in Signals we have these analysis dashboards, and these analysis dashboards are providing you and they've had some machine learning and AI that we really haven't been talking about, but they provide this ability to do the querying, the visualization, calculations, and a lot of this is in like with structure activity relationship, for example. And what we're also doing is, providing, extending some of this with, our linkage and our relationship with Spotfire, um, providing access to partners to link into our system to provide scientifically relevant integrations, and then we're using a lot of these APIs and things like that to provide the Revvity Signals extensions themselves. And so then, again, there's that QR code if you'd like to learn more. And so now I think it's time to jump into some questions. And there's a lot of questions here, Zev, and I just want to let everybody know that's listening that we may not be able to get to all of these, but we would be able to follow up with you afterwards. So Zev, have you had a chance to look at any of these? Anything that you like in particular? No,
So
I'm
yeah, no, I haven't, but I'm happy
okay.
to
Let me let me
answer
let me
them.
jump let me jump in then. I was just giving you the first opportunity there. So
Thanks.
so let's see here. Okay, yeah. So this first one here strikes my fancy. So, does the image analysis also work for particle analysis, form factor analysis, like roughness, colloidal particles? It's kind of like a material science kind of question, I think, in some regards.
Yeah,
Is this mainly cells, or does it
it,
also work for like
it,
particles?
so I'll answer that question, but probably not exactly answer that question. So it is made
Okay.
for cells. It is specific. That was like its goal. But let me give an example of something that kind of goes along with in that direction. So we had a customer ask us, if it could capture, morphology like size or texture. This is important because if you're in drug discovery and you understand kind of the cells, they go through apoptosis, so that's cell death, and you want to be able to measure that or count the cells, et cetera, those kind of things. Look for viability, especially if you're looking for safety or something like that, or maybe you're looking to kill the cells like cancer. So the short answer to that question of can we understand, the various different stages of cells? So it's not just a cell; it's like kind of crush or the various different imaging qualities of that. Is yes, we will be able to. It is not currently available though. So I guess to formally answer that question of particles, I would say the answer is no.
Hmm.
Um, but that's really interesting, and maybe there's something that we could follow up to understand sort of what the overall goal is with understanding particulates with this. But yeah, we have a really extensive what's it brochure or paper on how we've done how we've trained the model, what kind of model it is, the various different cell types we've used, the magnification. So we have thought a lot about this. But yeah, it's very, very much specific to cells. So I would say the answer is no for particles, yes for cells, and various different cell, what's the word, throughout the cell cycle. Yeah.
Yeah, I think that answer makes sense because I think as Revvity we focus a lot on life science, and some of that is of course, like as you said, we have to find like kind of like understand a little bit about what the needs are, but that sounds like more of a material science kind of question. And so yeah, I think that's good. So let's move on to the next question. I think that they're another good question. I mean, these are all good questions, so they're hard to kind of choose here. So one is on that chemical reaction recommendation. So
Mhm.
are these recommendations based on the tenant's own like Signals Notebook or Signals Research Suite data? And if so, can it be extended to use literature data, for example, via like SciFinder or retro synthetic tools such as Reaxys? How is your scores? How is the score for the reagents determined?
Yeah, so that's a really great question. So, to my understanding, the model was built from a very concentrated and controlled data set. That doesn't answer the question, but that is the same for everyone, or at least my understanding will it'll be kind of the same base for everyone. But I think where the question is going, if I'm interpreting it correctly, is can I use my own data or can I give it some other training data that is really important to me? And I think the answer is yes. And I think our goal is to really provide the ability, whether it's training sets or other algorithms that are really impactful for your science, that we will be able to put that into a learning model or provide that as a model. So I know it's a little bit of a broad answer, but I think like the last thing I'll mention is, I'm in one tenant. Does the other company in a different tenant see what I'm doing? The answer is no. But I think from a base model, I think everyone is kind of starting out with that kind of same, because it wouldn't make sense why we would, have different models for different tenants unless the companies themselves wanted to input, which the answer is yes, and I think we would be able to do that. So little bit of a convoluted answer there, but the goal is getting what you need for your particular company, as quickly as possible. And I am able to connect you with one of our people in strategy if you're really excited. So maybe we could follow up if that's something of interest.
Yeah, so I think Zev, you kind of answered another question that someone had asked kind of on this related topic about
Mhm.
like keeping the data separate. Our intention is
Yes.
to, with these tenants is intellectual property protection because we know how important that is for
Mhm.
everybody, and to keep all that separate.
Right.
So that was great that you kind of hit on that. I think that was excellent.
Okay. Perfect.
Okay, so let's see here. Okay, so here's a question about the data factory capability. So you just showed so the data factory you just showed to get data consolidated into the lake house. Is that available as a product from your side?
Is that available as a product from our side?
Well, they
So
just want to know if like data factory is a capability that we provide in Signals Research Suite.
yeah, it is. And I mean, I think I'm, I'm trying to interpret the question. I mean, I think the important piece is, being able to centralize the data. And so
Hmm.
that's kind of how the data factory is going to support. One question that wasn't asked, but I'll just quickly riff on it, and I think it's important, is this idea of sort of late stage binding schema. So, for example, you have a bunch of data, and then something changes, you learn something new, and you need to kind of, in some cases, reclassify your data, whether it's just simple metadata, or maybe something more interesting, like you want to impose an ontology onto your data sets, assays, genes, whatever the things you want to do. And the one thing I'll mention that is one of our strengths, and we're working on to really improve that, is to provide the ability for, this is mainly to your super users, right, where they can have the ability to, link metadata or link ontologies or things, provide layers that's really useful maybe for AI or ML or just searchability, et cetera, onto your data set. And I think that's one of the things that you can do. And it probably starts, or at least from either an API or a programmatically way through the data factory. Um, Obviously, I'm simplifying a process that probably takes months, if not, a little longer, talking to different scientists, understanding their science, understanding what they need and how they need to classify things, et cetera. And it would be a company-wide kind of, what is it, endeavor. But the ability is there, and we're making it easier and more to do that faster. And I think that's something that is going to be, really helpful when we think about, using it for artificial intelligence or machine learning.
Hmm. Yeah, so I mean, yeah. So the answer to the question is yeah. There's a data factory capability in Signals Research Suite, and maybe I'll just add that if anybody has kind of used what we were calling Inventa, it leveraged the data factory to do like structure activity relationship or the
Mhm.
biosar.
Yep.
And then another thing additional to that is I know that there's this mention of lake house or and that reminds me of like the data lakes and sometimes what people do is they utilize like or Signals Notebook or Signals Research Suite to kind of contextualize data, do some processing analytics and stuff, and then use the APIs to move it to a kind of their own data lake, whatever you choose to be that data lake. But
Mhm.
so people will do that as well.
Yep. Yeah, lots
So
of options and flexibility, which I think is
exactly.
key
Yeah,
for
I think
what
that's
people,
key.
may need.
Hmm. Yeah, I agree with you. Okay, so let me just go through some of these questions here to find another. There's so many interesting ones. It's hard to choose here. Oh, okay. Here. Let's see what this one says. Here, say. Okay, yeah. So this is part. There's like a two-part question here, and some of it might be something we feed into development, Zev. But
Sure.
the question was talking about the large language model and the semantic search. So The
Okay.
translation tool is indeed something that may prove very helpful. Looking forward to
Mhm.
this feature. I have two questions in that direction. So
Yep.
will the search term also be highlighted in the foreign language?
Yeah, that's a really good question. I don't know that answer because like Chris said, we're only in the still in the early stages of seeing some of these prototypes and what they can and can't do. And we actually haven't seen like what I showed you, although kind of you saw some of the product, it was still kind of a prototype. So that's a really great piece of feedback. I will definitely share that with our team. I would hope so, as someone who does a lot of searching myself. You want to be able to find what you're looking for. And especially if you're looking at a language that's not native to you, how would you, know if the search term you're using or the whatever within the language is it if it isn't highlighted. So I think that's a really great
If it
piece of
matches,
feedback.
yeah. So that would
Yeah,
be
if it
good for
matches.
our,
Yeah,
yeah. So for our development team, I think to so
exactly. Yep.
I'll
Yep.
flag this question as something that we can feed into them. And the other
Yeah.
question, Zeb, I think is that there's a two part to this with, and I
Yeah,
think
go
this
ahead.
one also is difficult for us to answer, but it's like the U.S. system, like if you have like $1.25, use like a decimal, and the Europeans will use like commas. And
Oh,
so,
okay. Yeah,
yeah,
sure.
yeah. So
Sure.
the person's asking here, like, will this be able to handle like a comma-based number system versus decimal? So I
Great
think,
question.
yeah, I don't know if you
Yeah,
know
well,
the answer, but I was
we
just going
don't.
to feed it
No,
into.
no.
Okay, yeah,
We don't,
okay,
but I would say I'll say this. I'll say this. I think our primary focus right now um is to kind of get the scientific uh aspects of things. I think that's what we're prioritizing, or at least I'll verify that. But yeah, I think all of those are really good points. And whether you're maybe outsourcing some science and you're communicating, the amount or something. But we definitely will pass that on.
yep, yep, absolutely. All right, so here's another one. So I think this is coming. The question, the timestamp on this question it was around the time when I believe you were talking about the cell imaging.
Hmm.
And they also asked about antibodies. So is anything like this available for beta testing? And you mentioned like we were interested in having people like test some of this stuff. So I'm very curious to explore the antibody and imaging aspects.
Sure. So we will have to follow up with you on the antibody developability. Oh no, that's not true. In some cases, it is. Parts of it, I think, are available for that. So if we can find you, if you're a current customer, we can follow up with your customer success and account manager and work with you on that. And then as far as the phenologic AI, that was just released. So late December 2024, and then I think the formal release, whatever that I think it was like 2 days ago. So that is available. To upgrade or add on. So I think that answers the question, but we're happy to follow up and make sure that yeah, you can get some hands-on or see what that might look like, especially if you have some data to use it on.
Okay. Yeah, yeah, we definitely would do that. Um, and we'd love to do that. So,
Mhm.
I guess another question. We're starting to get close to time, and I'll have to do a wrap up, Zev. But maybe this is your last question, or maybe we have, depending on how long this takes. So, can you extend on why you need mini AI models? Is using prompts and language large language models not enough?
Yeah, it's a really good question. I mean, I think the short answer is it isn't enough. And if you were to say, show me the best molecule for this type of cancer, and you type it into uh, ChatGPT or one of your favorite large language models, it's not going to be able to come up with a new one, and it's not going to be able to help you, find what you're looking for in that regard. So some of these models really do need to be curated with smaller data sets or more meaningful data sets for the particular science. It really needs to fundamentally understand that. Um, I, who knows? I can't say whether large language models will never be able to, will be one length or one model to rule them all kind of thing. But what we've seen ourselves and also with our customers is that's not the case. It's kind of these sort of many models specific for the scientific area. I think from a large language standpoint, you can still do a lot, um, but yeah, it's we're taking the approach of kind of the ease of use of our software with the generative AI and the large language models, and then for the scientific aspect, we're really trying to focus on, as we've shown, whether it's chemical reaction recommendations, antibody developability, or imaging, and there's going to be more. These are all three different models that are being used to support. And so, yeah, that'll be my hopefully short answer to that question.
Yeah, I think that's good. I mean, I think part of the problems of is that, with this AI, it's, we're, we're often thinking like when we watch sci-fi movies and you think a lot of these, you think of like having AI as having general intelligence like a human, but a lot of this AI is very focused. And I know that you've talked about like AlphaFold, for
Mhm.
like folding and like protein folding before, and then earlier you mentioned DeepSeek that it's using like different, it's going about this in a different way. um,
Yep.
and so, when people have mapped, I've seen presentations when people have mapped all these things out with all the different large language models and different AI flavors and stuff like that. They haven't really converged, like kind of like you say with your Lord of the Rings kind of reference, the one AI to rule them all or whatever. But yeah, so I think that's what you said there is true. Okay, so I think we're just about on time, and I'd like to keep everybody, be respectful of everyone's time. So let me move in here to a few announcements as we close out here. So Zev, would you put it on the? I don't know if it's yeah, that one. Uh-huh. All right. So we had a really good series of questions, and I'm sorry that we weren't able to get to all your questions, but we'll try to follow up with these as best we can offline. And also want to thank Zev for your sharing all these excellent um, examples, and thank everyone for attending today. So I just want to leave you with a few announcements. So the first announcement is our next Signals Connect will be March 20th. And if you have any ideas or topics that you'd be interested in hearing from us on, just